Yeah, so there is a kind of old relict from my LMU slides here, which is the case Kröger versus Tresp. So Volker Tresp is a very, very well-known machine learning guy, specialist, who is also professor at LMU. So he's a principal at Siemens actually, but he has a second job, so to say, and is official professor also in at LMU. And well, we know each other quite well, but we typically had, well, I talked about the curse of dimensionality as I did it just in the last couple of 30, 40, 50 minutes or something. And mostly at the same time when I was giving my lecture at LMU, also Volker did his lecture on machine learning at LMU, and he talked about a blessing of dimensionality. And at some point in time, our students actually didn't know who to trust. Yeah? So Kröger talks about the curse of dimensionality, or that dimensionality, high dimensionality, is a curse. And Volker Tresp actually was talking about kernels and stuff like that, where you pump up the data space in order to get better features. So in that case, higher dimensionality is actually a blessing. So who is right? Yeah, that was actually the question. So just that you know, yeah, we said just here in this lecture, the higher the dimensionality, the worse is the expected outcome of the mining algorithms, because patterns diminish and stuff like that. So we said that dimensionality, high dimensionality, is a curse. And but that need not to be the case in general, because, for example, the kernel tricks for support vector machines shows the opposite. So the extension, the pumping up of the data space with new attributes, the mining algorithm, for example, the support vector machine classifier, gets more accurate. Yeah, so that is the case where higher dimensionality is actually a blessing. And yeah. The students at LMU were absolutely right to ask who the fuck is right, and we had to say, well, we are both right, not because we are both professors, but actually we are actually both right. It can be a curse and a blessing, and of course the answer or the reaction of the students was, what the fuck? Can you somehow explain why? And of course there is an explanation. And once again, we just have to look at the different assumptions. So we assumed for the curse that the attributes are independent and often also even uniformly equally distributed. Yeah? So these attributes, if they are independent and uniformly distributed, they are most likely irrelevant for a data mining task, because they are just noise. They are independent, they are equally distributed. That is typically noise. Yeah? That's exactly what we call noise. Yeah? So these attributes are likely to be irrelevant. If we have a lot of those things, we have a curse. The blessing says, well, a kernel, if it works, adds relevant attributes. It also increases dimensionality, but it tries to add relevant attributes, and if it works, it obviously added relevant attributes. Yeah, so even more relevant than the original ones. Yeah, and that is what we had before in the discussion. If we have 500 super relevant attributes for a given pattern, we have no curse. And if we even add some more super relevant features for the patterns, which are maybe also not redundant to the original ones, we have a blessing. But if we have a lot of super irrelevant features, yeah, meaning noisy features, which do not add some information about our patterns, we have a curse. Yeah, and that is exactly the point which you have to keep in mind, that high dimensionality can be two sides of a coin. It can be a curse, very often it is a curse, but it can also be used to get a blessing. Yeah, so relevancy of features is the key point here. Yeah, that's the key point, and we will talk about how to actually identify relevant features. Yeah, because we want to get rid of irrelevant features. Yeah, so the message is high dimensional data is tricky, and the curse can come by several problems. Yeah, so due to irrelevant attributes, we have the curse. So try to get rid of the irrelevant attributes and keep only the relevant ones. And we'll talk about how to do that actually. Yeah? Yeah, and some are instead of relevant attributes, they are just redundant. So among the relevant attributes, we may have redundant attributes, which actually give you the same information. Yeah, so you also want to try to get rid of those redundant ones and just keep, one copy, so to say. Yeah, so those are the basic two problems when we have a curse. Irrelevant attributes and attributes that are relevant, but they are redundant, a copy of other relevant attributes. And we want to get rid of both of them, actually. Yeah? And we will talk about that, how to do that, actually, in the next couple of weeks, actually. Yeah, and we'll start next week with these things. So for this week, that's it. Approximately 2 hours of cursive dimensionality. So just reconsidering, we talked about the challenge of high dimensional data for data analysis. Yeah, the cursive dimensionality problems for data analysis. And the most important point, as we just said, is we have to get rid of the irrelevant attributes and maybe also the redundant attributes. Yeah? And we'll talk about how to do that in a supervised setting, but also in an unsupervised setting. And we start next week with feature selection techniques, and we'll also have a look at feature reduction techniques next week. Yeah. So stay tuned, stay healthy as always, and see you next week. Bye-bye.